Hello everyone, my name is Aitor Alvarez-Gila and I'm a part-time PhD student at LAMP under the supervision of Joost van de Beer. And I'm also a worker at Technalia and my advisor there is Alvarez-Garrote. So today I'm presenting you MVMO, which is a dataset for multi-view semantic segmentation. So MVMO is a multi-view, multi-object dataset comprising more than 100,000 scenes, each of them composed of 15 to 20 objects of 10 different categories, sampled from ModelNet 10, which is a 3D shaped dataset. And we place them randomly on the z equals 0 plane, and we applied a diversified appearance in terms of bidirectional scattering distribution function. We sampled all these scenes from 25 different camera locations and 3 different focals from the upper hemisphere. So the motivation of this dataset is that single view performance in dense prediction tasks is typically hindered by occlusions between objects, ambiguous views, which is worsened when we have fine-grained categories, and the small apparent-sized objects. So our goal with MVMO is to boost research in multi-view dense prediction tasks. And so we provide ground truth annotations in terms of semantic segmentation for each of the views. But we would like to go further and provide additional annotations in terms of instance segmentation, depth and normals, etc., to support research in additional tasks. So this is ongoing research being conducted over MVMO, and we asked ourselves the question on whether we could benefit of a multi-view approach for dense prediction tasks to improve the prediction. And the problem with this is that fully supervised baselines scale badly to multi-view setups because it requires to annotate every view. So we adopted a semi-supervised approach in which for some of the samples in the dataset, we annotate just one of the views, and for the others, we leverage the simultaneous multi-view and labeled captures, which should be cheap. And the expected outcome is given a scene captured simultaneously by different views to get an improved dense prediction from one of them. And this approach was based on mix and match networks, which is a previous work by our group, and it was adapted to account for explicit cross-view transformations. And it was successfully tested on a MNIST-based planar scene dataset, and right now we are working on applying it to MVMO on its current and future versions. So the main challenge we found when working on this project was that the idea came first, and then we found that there wasn't any suitable dataset for multi-view semantic segmentation. The few existing ones were camera-centric setups, where multiple cameras lie in the center and they sense the surrounds. And as opposite to these, we were interested in scene-centric setups, where the scene is in the center and the cameras capture it from around. So we had to create the dataset ourselves. And on the personal side, let's say that remote work and remote supervision require extra effort from both sides. And it's also hard to find a steady dedication while working full-time, especially so while teleworking with 2 small kids at home in pandemic times, but hopefully we'll make it.